In this video, I want to solve exponential equations using the inverse property. The inverse property is to take logs. Hold on here. Oh, I'm on the wrong. Take logs of both sides. Log of each side. This is when we have our variable in the exponent. That's why they're called exponential equations. So just take log of 4 to the x equals log of 13. Now what does this do for us? Well, the property of log says now we can take this x out in front and say, well, this is x log 4 equals log 13. And if I divide both sides by log of 4, I can cancel that off, and I have x is equal to log of 13 over log of 4. Now that's the exact answer, and you should know that an exact answer versus an approximation, but sometimes we need to know what that approximately is. I'm going to use this calculator, so a little more friendly than the other one. Log of 13 divided by log of 4 is approximately 1.850. Let's verify that seems to work. So on the calculator, I'm going to just kind of keep this value here, but take 4 and raise it to this power. Let me copy that, put that right there, and see what I get. And I get 12.9. It's really 13 because of all the rounding errors way out in the very small reaches of this number. So this works. Now, in the next equation, we have e as the base, and so that's the base of the natural logarithms. Excuse me. And so it's natural to do a natural logarithm of both sides. E to the 4 minus 3x equals natural log of 6. I took the natural log of both sides. Now the natural log of, with this is base e, of e to the 4 minus 3x, you should know this fact that that's just going to be 4 minus 3x. And then this is natural log of 6. Now, from this point on, it's just some algebra. Subtract 4 from both sides, and then divide each side by -3. And I get x is equal to this expression here. X is equal to the natural log of 6 minus 4, all divided by -3. Let's take a look at that. This over. So the natural log, and that's in the numerator. So let's put parentheses around this. Natural log of 6 minus, close that off, minus 4, close that numerator, divide by -3. And what we get is 0.736, about 0.736. And with these problems, it's a good idea to check that we've done this right. So this is E. We'll find E here and raise it to, and I'm going to put parentheses around that expression just to be sure, 4 minus 3 times, and then this is our x. Copy, paste, close that off, and let's see if that gives us about 6. Yes, it does. It didn't seem to give us quite exactly 6, but it does work. Now this problem C, I'm going to use the same kind of idea that I used over here with the natural log of e, because the base of the natural logarithms is e. So the base here is 8. The book tends to use this method. It'll say, well, the inverse of 8 to the x is log base 8 of 8 to the x equals log base 8 of 0.165. And not every teacher teaches it this way. I've seen it both ways. But here's kind of the beauty of this. Log base 8 of 8 to the x is x. And on the right-hand side, though, we have this different looking expression, but change of base, if you understand change of base, the log base, just common log of 8 can be in the denominator, and in the numerator, just log of 0.165 over log of 8. And there's the answer. Now that's kind of elegant to do it that way. Let's do a quick check. So log of 0.165 divide by log of 8, and it gives us negative 0.866. Negative 0.866. We'll check that. And so we're going to say, well, what's 8 raised to the, and we'll take that there, paste it, and see what we get. We get 0.165 exactly, which is what we want, so this worked. Okay, and on this last one, this is 1.43 to the a power, a little hard to see, but plus 3.1. Well, we want to isolate. It's going to cancel, and we get 1.43 to the a power equals 5.38. Now this is where this looks a little weird to use this last method, but it does work. And what's the inverse of 1.43 to the a power? It's log base 1.43. It's kind of weird. 1.43 to the a, but it's still legitimate. Log base 1.43 of 5.38. There is such a number. I mean, it does work. The thing is, log base 1.43 of 1.43 to the a, that's just a. Doesn't matter what these, as long as these things match up, the base and the base of this exponential expression, that'll just bring us back to a. And on the right hand side we have a change of base. This is just log of 5.38 over log 1.43. I'm not going to go any further. You can figure that out.